Hello everyone, and welcome back to the channel. Today, we're diving deep into a critical safety procedure on board any vessel: closed-loop communication. Miscommunication can lead to serious incidents, especially during high-stakes operations like mooring. That's why mastering this technique is non-negotiable for every member of the crew. So, what exactly is closed-loop communication? Simply put, it's a three-step process. The sender gives an order, the receiver repeats the order back to confirm they've understood it, and finally, the sender confirms that the repetition is correct. It's a simple, powerful way to eliminate misunderstandings. Think of it like a conversation with a built-in fact-checker. It ensures that the message sent is the exact message received and understood. This is vital when the master on the bridge is coordinating with teams on the forward station, the aft station, and in the engine room, often in noisy, high-pressure environments. To really illustrate how this works in practice, we're going to run a full role-play simulation of a mooring operation. We'll follow the communication between the bridge, the forward station, the aft station, and the engine control room. Pay close attention to how every command is sent, repeated, and confirmed. This isn't just about following rules. It's about building a culture of safety and precision. Let's get started with our simulation. Imagine the vessel is now approaching the berth. The master is on the bridge, assessing the situation. The mooring teams are standing by at their stations, fore and aft. The engine room is ready to receive commands. The first communication will be from the bridge to the forward station. The master picks up the radio. Forward station. This is the bridge. How do you read me? The forward officer responds. Bridge. This is forward station. Reading you loud and clear. This initial check establishes a clear line of communication before any critical orders are given. Now, the operation begins. The master looks at the bow-S position relative to the pier and decides it is time to get the first line ashore. He gives a clear, concise command. Forward station. Send out the headline. The officer on the forward station hears this. He doesn't just start working. First, he confirms the order. Bridge, copy that. Sending out the headline. Now, the master knows the forward team has received and understood the instruction. He gives his confirmation and a follow-up instruction. That is correct. Let me know when the line is on the bollard. The team on the forward station works to get the heavy mooring line to the linesman on the pier. Once the line is looped over the correct bollard, the officer reports back. Bridge, headline is on bollard number 2. The master now needs that line to be tightened. Forward station, heave away on the headline. The forward officer repeats the command back. Heave away on the headline. Roger that. He then relays this to his team, who begin tightening the line on the winch. This loop of command, confirmation, and action prevents any mistakes, like heaving on the wrong line or at the wrong time. While the bow is being secured, the stern of the ship also needs attention. The master now turns his focus to the aft station. Aft station. This is the bridge. The aft officer responds. Bridge, this is aft. Go ahead. The master gives the command. Send out the stern line. Following the protocol perfectly, the aft officer repeats it back. Roger. Bridge. Sending out the stern line. The master now knows the aft team is on the same page. The stern line is sent ashore. The aft officer provides a status update. Bridge, stern line is ashore, waiting for it to be placed on the bollard. The master acknowledges this. Understood, reports when it is on the bollard. A few moments later, the aft officer reports. Bridge, stern line is on bollard number 6, aft station. Heave away on the stern line to make it fast. Heave away on the stern line, making it fast. Roger that. Bridge, the aft team begins to tighten the line. This back and forth ensures the master has full situational awareness and control over the entire operation, even though he can't see every detail himself. Now, let's bring the engine room into the loop. Throughout the mooring process, the engine is used to make small, precise movements to bring the ship alongside safely. The communication here is just as critical. The master, seeing the vessel is nearly in position, needs to adjust the engine. Engine room. This is the bridge. The duty engineer responds. Bridge, engine room, loud and clear. Engine room, dead slow ahead. This is a command for a very slow forward propulsion. The engineer repeats it back immediately. Dead slow ahead, understood. He then adjusts the engine controls accordingly. The master confirms, dead slow ahead is correct. This loop is vital. A mistake in an engine command like putting it astern instead of ahead could have disastrous consequences, potentially causing the vessel to hit the pier or part the mooring lines. Back at the forward station, the headline is now tight. The forward officer reports, bridge, headline is fast. The master replies, headline fast. Roger. He now wants to add more lines to secure the bow completely. Forward station. Send out the forward spring line. Send out the forward spring line. Roger that. Bridge. The team gets to work. Simultaneously, at the aft station, the stern line is now tight. The aft officer reports, bridge, stern line is fast. Stern line fast. Roger that. Now, send out the aft spring line. Send out the aft spring line. Roger. Bridge. You can see the rhythm here. It's a constant, controlled flow of information. The master is like an orchestra conductor, and the closed-loop communication is his baton, ensuring every section plays its part at the right time. Let's return to the engine room. The vessel is now perfectly positioned alongside the berth, held in place by the mooring lines. The main engine is no longer needed. The master gives the final engine command. Engine room, finish with engine. The engineer in the control room hears this critical command. He repeats it back for confirmation. Finish with engine. Understood. He then initiates the shutdown sequence for the main engine. The master needs one final confirmation. Roger that. Reports when engine is stopped. A few moments later, the engineer confirms the action is complete. Bridge, main engine is stopped and secured. The master closes the loop for the final time. Engine stopped and secured. Thank you, engine room. This entire simulation shows how closed-loop communication builds a web of safety and efficiency. Every command is checked and double-checked, minimizing the risk of human error. It creates a system where everyone is accountable and aware of the operational status. This practice isn't just for mooring. It's used during anchoring, in pilotage situations, during cargo operations, and in any scenario where clear, unambiguous instructions are essential for safety. So, what are the key takeaways? First, always repeat a command back to the sender. Second, wait for confirmation that your repetition was correct before taking action. And third, always report back when a task is completed. By embedding this three-step process into every communication, we transform a simple conversation into a powerful safety tool. It fosters teamwork, builds trust, and ultimately keeps everyone on board safe. Thank you so much for joining us for this demonstration. I hope this role-play has made the importance and practice of closed-loop communication crystal clear. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe to the channel for more content on maritime safety and operations. Stay safe out there, and see you in the next video.